Hey, welcome to today's notes. We are starting the new semester, starting the new unit. Unit 8, the cell cycle. So let's take a look at these notes. That we're doing today. So the cell cycle is the overall unit. And today, the first part of that unit, 8.1, why do cells divide? So the average human body has 37.2 trillion cells. That's trillion with a capital T. So there's a lot of cells in your average human. But why so many? Why not 1,000? Or 100? Or just one? Why aren't we a big, gigantic, single-celled organism? And why are cells so small? Well, really for two reasons. We're going to look at those two reasons today. First reason is the surface area to volume ratio. And again, it's the ratio that's important here, not really just the surface area, not really the volume, but the surface area to volume ratio. For a cell, the surface area is the cell membrane. Kind of going back to a little bit of last semester, you guys remember the phospholipid bilayer? Those lollipops with two tails that are facing away from each other, tails in the middle. Well, that's the cell membrane, and that's the surface area. That's the surface of the cell. The cell membrane is responsible for bringing nutrients into the cell, for that matter, for getting waste out of the cell. Now, as the cell grows, its surface area does certainly get larger, but the volume gets larger faster. And again, that's why that ratio is so important. So let's take a quick look at that kind of in detail here and put your artistic ability to work. So we'll compare three things: the surface area, the volume, and the surface area to volume ratio. So yes, cells tend to be a little bit more spherical shaped than cubical shaped, but the math is going to be a lot easier if we work with a cube. So here's my awesome artistic abilities. It's a cube. We'll call, and it's probably not accurate at all, but we'll call the side length, the edge, 1 centimeter. For the surface area, we do 1 centimeter by 1 centimeter, so length times height, times 6 sides to the cube. And we'll get 6 centimeters squared as our surface area for this small cube. For the volume, length times width times height. So 1 centimeter by 1 centimeter by 1 centimeter. Don't need a calculator for that one. 1 cubic centimeter is the volume of this small cell. So the surface area to volume ratio, 6 to 1, or 6 times. The surface area is 6 times greater than the volume. So that's for a small cube. What if we make a larger cube? Really putting my artistic abilities to work here again. That's a pretty poorly shaped cube, and that's the best I can do. So here's a larger cube. We'll call the side length here 5 centimeters. This is a much larger cube than our first one. Again, the surface area, length, make sure to put our units on that, times height, 5 centimeters by 5 centimeters, times 6 sides. Do the math right. And we get 150 centimeters squared as our surface area for our large cell. For the volume of our large cell, length times width times height. So 5 centimeters by 5 centimeters by 5 centimeters, 125 cubic centimeters. So, okay, our surface area is huge. Look how big it is compared to what the little one is. It's much larger, but so is the volume. That's why we need the ratio. When we divide our 150 by 125, we get a ratio of only 1.2. In our small cell, our surface area was 6 times greater than the volume. In our large cell, the surface area is only 1.2 times greater than the volume. It's going to be a lot harder for this surface area to get enough food to the inside of the cell for this to work. And that's why cells have to stay small. There's a maximum size that cells can get. And at that point, you can't get any larger. You can't feed the entire inside of the cell. Now, all that said, there are some advantages to being a really large cell, to having a very large volume. There are some advantages. You can do a lot more work. You can get a lot more accomplished if you're a large cell. A lot more energy can be expended. So, one more little bit of artistry here. Draw another big cube. But this cube, we're going to make out of smaller cubes. Again, me being not an artist, not a very good picture. But here we have smaller cubes making up a much larger cube. It's like smaller cells making up a much larger area, or a multicellular organism. Oh, there's going to be 125 of these small cubes in that block. You can double check the math if you'd like. But there's going to be 125 of them. So if I take my surface area of the first cube, and I've got 125 of those cubes, I'm going to end up with a surface area of 125 times 6, or 750 square centimeters. So I've got this ginormous surface area because each one of these cells, each one of the little tiny cells, has the same surface area as this cell here. My volume is going to be the same volume as the big cell. Got that same volume. Let's make sure we're sure about that. 5 centimeters. There we go. So I've got the same volume as the big cell, the same surface area as the small cell. When I divide those two, then, when I get my ratio, I've got the volume of the big cell and the surface area to volume ratio of the small cell. And again, that's the important part. We're using that surface area to feed the volume. It's the surface area that gets material into the cell. And that's where we have multicellular organisms, much larger volume, a lot of more work can be done, but made up of small cells. Those little cells have the surface area to volume ratio to feed the inside. All right, all of that though, it's just the first reason. There is a second reason as well. Our second reason that we have small cells and lots of them is called differentiation. Your cells perform different tasks. For instance, red blood cells carry oxygen. Nerve cells send signals. These are completely different tasks we have to have being accomplished here. Each cell is built in a way that it's able to perform its specific task. Red blood cells are built specifically to carry oxygen. They have a very unique shape, just so they can carry oxygen. Nerve cells, the same but different. They are built specifically to send signals. You would not want a red blood cell sending signals, and you wouldn't want a nerve cell carrying oxygen around. They couldn't do it. They wouldn't be able to. Red blood cells and nerve cells are as different looking and different behaving as fish and giraffes. You can imagine a fish trying to stretch its head really high to grab food off of a tall branch, or a giraffe trying to swim around in the middle of the ocean. It just doesn't happen. Just like a red blood cell doesn't try to do a nerve cell's job. This division of assignments that the cells in your body take up is called differentiation. Differentiation. And that's another reason why we have so many but very small cells, is that your small little cells, and as many as you have, they all have different tasks to do to keep you running. All right, well, thanks for stopping by today. Thanks for getting the notes. We'll see you guys next time.